Welcome to the statistic learning session. In this presentation, we'll explore efficient method to compute Tn, the supremum of absolute difference between empirical cumulative distribution function f and t and a test cumulative distribution function f naught t. By leveraging the piecewise constant nature of f and t, we can identify the specific points where maximum discrepancy occurs, significantly simplifying the computation process. Now let's begin. First of all, we need to identify the observations. If there are not enough observations, consider how this may impact computations. We'll denote the computation, we'll denote the cumulative distribution function CDF of test distribution as f naught t and empirical or statistical hammer CDF as fnt. Next step, to compute Tn, we need to evaluate this. Can you tell me, okay, before I write it, can you tell me what we need to evaluate? Let me tell you, it's going to be Tn sup t f fnt f naught t. Now, recognize this. Recognize that fnt is a piecewise constant which jumps at observed values t I equal to xi, where I can be 1 through n. Now, let me create a graph here where there are two rows and this is a x-axis, this is t, and this is a f naught t. Now we have this piecewise constant like this, like this. These are a piecewise constant, and these are observed values here. That is, these are observed values here. These are observed values here. Now, we need to arrange that in the increasing order. So these are increasing order. These are order statistics. Now, let's break down empirical CDF. Empirical CDF, FNT, is statistical hammer CDF, takes discrete values of its order points. That is, let this be 0, and this can be 1 by n, and this can be 2 by n, and so on until it reaches 1. Now, let's understand the behavior of FNT. At each jump, FNT increases by 1n. Between jumps, it remains constant. Now, between jumps, it remains constant, but at each jump, it increases by 1/2 n. Now, compute Tn. The supremum discrepancy between fnt and f naught t occurs only at jump discontinue points. That is, it becomes maximum Tn equal to max fn x t f naught x I and I can be 1 through n. Now let's do an example here. So let's n is if n is 4, then there are 4 observation points here, and it's going to be 1 by 4, 2 by 4, 3 by 4, and 4 by 4. At each jump, the function progresses stepwise from 0 to 1. Now, this we have already plotted this sequence or this line. Now, to identify largest absolute difference between f and naught, we have to use a formula here that we will discuss in later series. So let me summarize what we learned today. This method efficiently computes Tn by focusing solely on the points of discontinuity in f and t. By leveraging order statistics and stepwise nature f and t, computation is significantly simplified. This process highlights the importance of understanding behavior f and t to identify critical points of discrepancy. Now, next step is to highlight the point of maximum discrepancy as critical for further statistics testing. That's all for today. I will see you next learning session. Thank you so much. Have a nice day.